Abbiamo colto l'occasione per invitare due esponenti molto importanti di MapR, che sono appunto Fabian Wilkens e Tugdual Grall. Tugdual parlerà di drill, di Apache Drill, mentre Fabian parlerà di microservices e stream-based architectures. Quindi avremo questi due interventi, chiaramente è un evento aperto, potete intervenire, sarà in inglese e vi spiegheranno appunto quali sono i punti di forza di questi due strumenti, che sono strumenti di punta di MapR. Mi sembra di non avere altro da aggiungere, se non che c'è, vedete qui alle mie spalle, un codice sconto per partecipare alla Web Summit di Dublino, quindi per chi volesse può approfittare di questo codice sconto. Vi ringrazio e diamo la parola quindi a Tug, che è Evangelist per MapR, giustamente, grazie.
So, how much time do we have for this? 6:30 until?
So, yeah.
Till which time?
Half an hour would be
fast.
All the time you need.
No, if you need more time,
No, but you have to give me your time because I can talk for 2 hours.
No, 40 minutes.
So we talk about drill tonight when we organize this event with Monica and Fabian. One of the topics is about accessing the data using, for example, SQL. And you will see why it's important. So as a quick introduction about myself, so I am Tug and I'm coming from France, as you can guess from my accent. And I used to work in many vendors like MapR, MongoDB, Couchbase, Oracle, and I really like databases and applications and what you do with the data. And as part of that, my job is really to help the community to adopt MapR and big data globally. So if we look at what a big data project is, you have 4 big topics you have to deal with. You have to ingest the data, and Fabian will talk a little bit about that later on. You have to store the data, you process, transform, and enrich the data, and you consume the data. And today I will mostly talk about consuming the data, querying the data. Well, you will see that you can also even process it using SQL, but I won't go into much detail. What is important, if you probably have seen that in many topics on Hadoop user book already, but it's when we talk about ingestion and storing, you have many, many options. You can, for example, on the storing part, choose using files, database, using external database, like relational database or NoSQL database, outside directly MapR or Hadoop. And you will see that we need to access this information when we want to consume. I'm working for MapR as a converged data platform that provides you MapR file system to store the information that is accessible using NFS, simple NFS protocol, but also HDFS. MapRDB database that allow you to use HBase APIs plus JSON documents, and even streaming, so using the Kafka API to condition support event in a very scalable way. And the next presentation will talk more about that. And at the top of that, you can use many of the open source APIs, starting with the whole Hadoop ecosystem to build applications. Spark is huge in the way you want to build application also. But tonight, I will mostly focus on Apache Drill. That is one of the components that you can use, one of the open source components you can use to build applications and create a database. And if you want to see more about what you have inside MapR, you have obviously this high-level slide, and you have the whole Hadoop ecosystem that you have inside available for you. So let's start directly with drill. So one of the key parts is why do you need drill and why drill has been built. The most important part, and it's huge when we talk about big data on Hadoop, is most of the data we are dealing with are not in relational database anymore. You have many solutions that have been used to do that, like all the NoSQL market, all the Hadoop file system. And one of the 2 or 3 parts that are very important in this area is the volume that is increasing all the time. You have more and more data, and you want to keep the data because they have value for your business. But also the fact that they don't have a very defined structures, or the schema of the data will evolve over time. So this is two big stuff that you have to deal with when we talk about big data. But if you look at Hadoop, HBase, MongoDB, these three specific storage, and if you have the file system, you have different ways of querying the data. And one of the challenges was why cannot use SQL to access my data, to access the non-relational data set. Historically, SQL has been built to be compliant with a specific schema, but it has very, very good benefits. First, everybody knows SQL. If you talk about, if you go in any enterprise, any developer, maybe not the youngest, but at least developer with experience will know how to write SQL queries. But if we all know how to write SQL queries, it's also that all the tools know how to talk to SQL. A good one here is probably that use SQL to access the reporting on analytics on the data. But you want to keep the flexibility of the NoSQL market, of the Hadoop market, like no schema and no transformation. You want to store the data the way they are put inside the system and be able to query them. So the challenge was to keep to use SQL in a standard way, but using a large volume of data and using the flexible schema. So when Drill was created, the goal was to have a schema on the fly. We discover the schema. This is very important when you will see some of the queries that I will execute. I don't define any schema. I don't ask any schema before. I just query the data. The system will discover what are the different attributes, fields that you have inside the data. This makes the life a lot easier for anybody that want to discover the data. And this is unique for Drill because the other solution, if you look at a relational database, it's a schema first. Before doing anything, you have to create a schema. You cannot even save a single field if you don't create a table, if you don't create a column before. And for other SQL and Hadoop solution, you also have most of the time to create a catalog with the different columns you want to use. That doesn't necessarily match exactly what you have on this, but you will query using the catalog and look on the different columns on the CSV file, for example, but you need this schema first. That makes a little complex and harder the integration and the discovery of the data. It's an open source project. I won't go into the details. It's an Apache project. Many people are contributing to it. But let's go really into Drill. The most important part, Drill, it's not SQL on Hadoop or SQL on MapR. It's SQL on everything. And you will see that in the demonstration that I use different data sources and a very simple cluster, kind of. But to be able to do SQL on everything, you have to extend a little bit the way SQL queries are created. So one of the first parts, the select star from where will be the same, but in the from, you have specific naming convention. The first one will be the storage plugin. Which type of data do I want to manipulate? Do I manipulate the file system? Do I manipulate a database, a relational database, HBase, as a NoSQL, HBase or MapRDB, for example, or any other storage you can imagine. Then, depending on the first step, is it a file system, is it a database? The next one will be a schema or a folder, depending on the type of the information you will manipulate, what we call the workspace. It could be a subdirectory, a namespace, a Hive database, a database, if you are talking about MongoDB or Cassandra, for example. The last part will be either another element of the file system. It could be a folder, could be a star.csv or star. JSON, for example, if you are on the file system, or a table or a collection if you are talking about the database. So this is an extension of what we have done to the SQL, just to be able to kind of allow you to point to any type of data. And even in this form, we have extension where we can send metadata. For example, if you deal with a CSV file, you can in the form say, I want to take header or not, the first line being a header or not, header name. Also, we want to deal with flexible data. So relational database, CSV, HBase, and so on deal very, very well with row columns structure. It's very nice and very easy to do. So CSV, TSV, HBase, MapR, binary, Cassandra, all this stuff can do very well with that. But in reality, the complexity of the data, it's a lot more than simple rows and columns. A very good example is JSON. And internally, into drill, when we manipulate the data in memory, when we access the data on disk, and we load them in memory to do all calculations, aggregation, transformation, projections, and so on, we use a structure that looks like a JSON document. It's optimized. You may have heard about the Apache Arrow project. That is a vector of this data. But internally, drill can deal with complex data structures. Keep in mind, we discover schema on the fly. We don't necessarily have to say that a specific person has a name, a first name, or the last name. And if you see, this one has OSB on district, this one has OB on preschool. Different attributes will work, and they will be discovered on the fly. So, the best way to discover drill is to use it. You know SQL, so you will be able to quickly use this as a learning by doing it. So most of the time we use the database, dataset challenge from Yelp, containing many JSON documents, but you can find other documents, CSV, database, and so on. And when you work with drill, when you have installed drill, you have 2 or 3 ways to access the database, to access the data. I will say database, but in reality it's just a data store, depending on what you want to say. You have a command line interface, you have a web UI, and you also have a Drill Explorer that is a UI based that uses ODBC to access the information. What is important when I say ODBC? That means everything that I will show you will be accessible with any ODBC, GDBC tools. So any of the reporting tools, transformation tools like ETL and so on will be able to access drill queries of drill data if you need to. It's very flexible. So if you see at the data in Yelp, they are very complex JSON documents. So what I will do is I will just do a demonstration instead of showing you a slide. So let me share my screen. So can you read it? Okay. So what I have done is I have downloaded drill from the website, and drill 1.6 has been released today. If you want to test, I still have the 1.4 for this demonstration. And if you look at it, we have simple files, and in one of the folders you have a binary file that you can execute. This is a simple Java application running on my laptop. So what I really like about drill, you start with a single node on your laptop. You can do everything you want on your laptop. And you can scale to any size of cluster into a MapR or Hadoop cluster if you need to. So you can really discover the power of drill on your machine very quickly and learn. So what I have here is, I say in the slide, we will query the Yelp dataset. I will just take this query, copy and paste, and I will explain to you what happened. I query it here, execute, and it's working very well. So I forgot something. So I will show you the UI. This is what I was trying to do before the interview, and I messed up my installation. So when you want to configure drill, you will say, where do you want to look for the data? So you have the concept of storage, and the storage will tell you this is where you find the specific data. You will create workspaces, and this is where my mistake is. I want to look in this specific folder for specific file. If I go to this file, you see I have a set of JSON files here. So I'm just configuring drill to say, look in this location, you will have Yelp in the workspace, data, and so on. So saving the file. So now it's configured to access the Yelp folder. So if I go back to my query, I copy it. I can copy it here, execute. It should work. Okay, I got some information. If I go in the UI, you will have exactly the same result, right? So most of the time I like to use the UI, but you can use any tools you want. So one of the important parts is, if you look, I am querying a zip file, a compressed file, that is a JSON file compressed. And if you look at this specific file, in it's a 55 megabyte uncompressed, 7 megabyte compressed. And look at what I have done. If you look at one single document, select So this is a complex file. You can do it in the UI because I zoom it. This is the size of my file. Okay, multiple columns with complex JSON, and I have the city somewhere, and so on. And what I have done, you can re-execute queries and see what the performance was in the query. So I will re-execute it. And I will explain one very important part, the most important part of the unit. So I look at the query, I do a group by, I do a count, and so on. So what I have done is I do group by state, city, and you sort by the number of business you have. So it does a count, there's many, many interesting things, like group by state and city, order by business, descending limit 10. But you have to, what I am querying is a file system. So what happens behind the scene? He has to open the file, and he has to scan all, in this case, he has to open the file, uncompress the file, and scan the file. And what is important to understand about Drill, when you will query a system, you will pay attention to which type of storage you are using. If you are using a file system, and you work on a distributed file system like MapR or HDFS, you will distribute the query on all the nodes and do all the operations on all the nodes. But on a file system, the only thing you can do, scan, load that in memory, do operation in memory, return the value. If you are working with a database, like for example, install MongoDB, and I have MongoDB running on this machine. If I want to do close all the if I do a query like that into I add all my queries, but I close. If I do this query in Drill, what will happen is I have a where clause, right? Accessing a database named Yelp on the user collection. Imagine that for HBase, for MapRDB, for MapRDB JSON, or relational database. When I submit it, it returns one single row. But in this case, because the database is powerful enough, the where clause is what pushed down to the storage. So depending on the type of data you are using, you will try to push down the operation to the database when it makes sense. Okay? So you have to understand the type of data you are manipulating. And if I look at the profile of this specific database, if I look at the physical plant somewhere, I will have the filter that is sent to MongoDB. You will have the same for MapRDB, you will have the same for a relational database. So you have all the optimization you can do to have complex query and so on. And if you like colors, you can look at the projection. So this is not very interesting in this case. What I will do is I will do a more complex query with join between different data. Since I don't have a lot of time, I won't give you all the how I built this query. But what I will show you is I take a query And what this query is doing, it's a bug in Facebook, no notification. So look at the query. You know, when you look at SQL, you have to look inside. The first query is inside the join, and then you go out. So the first query is specific operation that I do on a JSON file and I flatten the categories. Flatten categories, what does that mean? It's when you have a JSON document with many lines, like this. So, this is some extension we have done to SQL. If you look at the top, on each line you have multiple values. How do you query that? How do you organize that? If I want to count how many doctors I have in my database, how it's possible with JSON. With standard SQL, with no extension, it's not possible. What we have done, we created a new operation called flatten that will transform each entry into a line. So kind of doing the opposite of a join, if you want. Now we have two lines to get the categories. So this is what I do internally to the first query here. Then I have a Parquet file. Everybody, Parquet, who knows what Parquet is? That means the other you don't know, so I will explain. So if you look on the file system, you work on file system like I did with a JSON file. It's not the most efficient way to manipulate document when you have JSON. You have to read the line, wait until the JSON document is parsed, then you can start to do some stuff. Go to the next line or next document and so on. And for many reasons in Hadoop, globally, so in MapR and all the Hadoop distribution, if you want to optimize the way you access the file system and access the data, you have to use specific formats. And we have many formats that have been created by the Hadoop community to be able to have a very, very efficient scan and also be compressed and distributed on all the nodes. Parquet is one of them. Dream is a favorite format. Parquet is a favorite format when you have to deal with a file system. So use Parquet whenever you can, instead of using JSON or CSV. We work perfectly with JSON, we work perfectly with CSV, but it will be a lot more efficient if you use a Parquet file. And so then I do a query on the MongoDB user, and I do a join between these three different tables on some complex query to get the most, I don't even remember what I will give you. So, reading a JSON file, exploding the JSON file with Flatten, doing a join to get the review into a Parquet file, so the review people have done on the website, then the name of the user to get, oh yes, what are the most active, which is the most active user for which categories in number of comments he has done. So it's a join between a database, a file system, and a Parquet. So you can almost do whatever you want in terms of queries, but how do you scale will depend on the data type, the number of nodes you have inside your cluster. Okay? So I won't go into all the extensions we have done to the SQL. You will see that you have many of them to manipulate complex data. What I want to show you, and you will have access to the slide, is which type of data source you can manipulate and how does it work when you have a large cluster. So out of the box, you have access to CSV's JSON Parquet file, Avro. Always, Avro is another example. Try to use Parquet whenever you want. All these databases, Hive, HBase, and MongoDB as a NoSQL databases. We are finishing MapRDB JSON. And MapRDB I didn't put it because it's the same API as HBase. The community is working on all this, Couchbase, Elastic, and so on. Cassandra is also. And you can also connect Drill to your relational database. So you can use SQL at the top of a relational database. It's quite exceptional. So the important part what I have said is not that obviously you can use SQL at the top of a relational database. You can join all this to your relational database. But don't do that as an analytic platform. What you do is you use this connector to kind of take the data into your cluster, create Parquet file from an Oracle table, from an Oracle query. Like that, you will have an efficient way of doing that. Because using a simple create table as select, you can create Parquet files from any query you want. And it will be distributed in your MapR or Hadoop cluster. So, all the labs, all the queries that I'm running, the sample, you can follow that on this specific workshop if you want to do that after the fact. So what is important about the architecture is when we talk about drill, what you run is a drill bit. What I have started is a drill bit. And you will deploy many of them depending on your cluster. But each of them have the same components and have the same behavior. So, first of all, you will run that on many machines. You will use an in-memory columnar execution, so in a very efficient way. This is Apache Arrow, that is one of the projects that the drill team and MapR team has created. And each node will be able to do coordination, planning, and execution of the query. Coordination is when you have multiple nodes, who will take the query and who will be the master for the specific query. Planning is how to organize that, especially how you will transform your SQL statement into a file system access, into a SQL statement to a relational database, MongoDB or MapRDB query. You can work it as a standalone node, like I have done, or on a network complex cluster. And you have JDBC, ODBC, or REST API. So obviously, the most used are JDBC and ODBC. If you want to access the data using a simple JDBC, REST API, you just have to do this. You see, I do a query and use a SQL statement, and we just use that, and it will return which is not working. If I do this query, I am executing this curl that will execute this SQL statement that return me this result with, this is a list of columns, and this is the row that I have. It's very nice when you want to integrate that to a small application. So, when you work with terabytes of data, you will have to work with the concept of data locality, try to put the process as close as possible to the data, and distribute the workload. So, I look at different systems here. You have HDFS or MapRFS. You have NoSQL database at the top of the distributed file system. It could be HBase, MapRDB. Or you have MongoDB, for example, or Cassandra, I won't say because I don't know how it's implemented there. And here I have my list. So what you will try to do when you deploy drill is to put the drill bit where the data are. Because when you will execute a query, drill, depending on the type of connection you use, the type of plugin, you will try to execute the read where the data are. So on the MapRFS, HDFS, you will know to read the chunk of data directly from the server. If you are using MongoDB shard, you will distribute the query on all the shards automatically. To be sure that you can scale. So how does it work when you have multiple nodes like that? So what happens is, here I have one client application that will execute a query. And all the nodes into drill are exactly the same. You don't have a master and slave. What happens is when you execute a query, one node will take this query. And for this specific query, it will become the format. But only for this query. If you add another query, this one will become the format for the query. So you will do the first optimization, try to understand, parse the query, do some optimization about the storage. Then you will start to execute and some specific operation to the other node. Each of the nodes will do the operations. They will exchange some data if they need for aggregations and sorting. And then when it's done, you will return back to the format that will return to